Good morning, everyone. I'm Xiaoxi from Renmin University of China, and it's my pleasure to share our latest work, CorpusLM, towards a unified language model on Corpus for knowledge-intensive tasks. And this presentation is divided into 4 sections. And first, let's start with the background introduction. Well, the large language models have recently revolutionized fields such as question answering, dialogue, and recommender systems, and they demonstrate impressive capability in various language tasks. However, the large language models often face the problem of hallucination, which means that the generated text may contain misleading and false information. And this thing is particularly severe in knowledge-intensive tasks, such as slot filling and open domain question answering, because these tasks are usually complex and require to get information from a large external corpus to achieve a higher performance. To address the problem of hallucination, a popular approach is retrieval-augmented generation, which is also known as RAG, which typically involves 2 modules, a retriever to obtain relevant context from a large knowledge corpus, and a generator to synthesize the retrieved context into coherent responses. And for the document retrieval task, existing works mainly involve sparse and dense retrieval methods. The sparse retrieval method represents the document and queries with sparse vectors in the vocabulary space, which is the back-of-word representation. And for the dense retrieval, this method represents the document and queries with dense vectors in the latent space, which is the dense embeddings. However, these 2 methods, both of them rely on standalone indexes to conduct the retrieval, which cannot be optimized together with the downstream generative tasks. And then comes to the generative retrieval method. This method represents a document with a short and unique identifier, such as a title of the document, which is namely the doc ID. And it employs a generative model to remember all the doc IDs inside their parameters. And given a query, the model directly generates the relevant document's doc ID through constrained beam search. And finally, we get the doc ID ranking list. Therefore, this method parameterizes the entire retrieval pipeline, and hence the retrieval task can be optimized end-to-end. However, the potential relationship between the generative retrieval and downstream generative tasks are often overlooked, and this is the main motivation of our paper. And then the method. This figure shows the overview of our model. The main idea is to use a unified generative model to handle multiple information retrieval tasks, including document retrieval and downstream generation tasks. Specifically, we involve 3 categories of tasks, which is shown here. And specifically, the generative retrieval and closed book answer generation and retrieval augmented generation. And in order to achieve the knowledge-intensive language tasks, involve the 5 categories of tasks. Through multitask learning, the model can learn shared patterns between generating doc IDs and generating answers. This mutual reinforcement between retrieval and generation tasks enhances the performance of both tasks. And besides, considering that the doc ID is a new concept for the language model, and the model haven't seen that before in their pre-training dataset, we also develop unsupervised doc ID understanding tasks in order to enhance the model's comprehension of doc ID semantics. And specifically, we develop 4 tasks as the auxiliary tasks, including the doc ID prediction tasks and the doc ID content recitation tasks. And that's the overview of our model. And besides, we also developed 2 decoding strategies for generative retrieval and RAG to further improve the model's performance and to achieve a unified greedy decoding solution for all the tasks. Specifically for the generative retrieval task, we develop a ranking-oriented doc-ID list generation method. In order to unify all of the tasks into greedy decoding, we designed the following step. First, we pre-built a doc-ID prefix tree offline using the title and subtitle of the documents. And these serve as the prefix constraint in order to guarantee the generated doc-ID are valid in the document corpus. And then the greedy decoding process. During inference, we employ a dynamic activation of constraints during the generation of each token. We identify that if the generated token is doc-ID start symbol, we enforce the prefix constraint. If the token is the doc-ID and symbol, we leave the constraint and remove the previous generated doc-ID from the prefix tree to prevent the duplication in the subsequent generations. That's for generative retrieval task. And for RAG, we also develop a 3-stage decoding strategy. Also, in order to unify all of the tasks into a single greedy decoding process, we designed the following RAG stages. First, we use the previous strategy to decode the relevant doc-IDs, and then we can map the doc-ID to the corresponding text and send the retrieved text into the decoder input. And then before decode the final answer, we propose to first decode the fine-grained references from the retrieved contexts, because the retrieved contexts usually contain irrelevant and redundant information, and that can hurt the performance of the final answer. This process is to filter the irrelevant and redundant information, and this process is somehow similar to the chain of thought, the concept of chain of thought. And that's the 2 decoding strategies. Now is the experiments. The experimental settings. We take the KILT benchmark, which is the knowledge-intensive language tasks. And this benchmark contains 5 categories of tasks and 11 datasets. The details of the datasets is shown in this figure. For the implementations, we use T5 base and Llama 2 7B as the backbone models. We also use full fine-tune for T5 and QLR fine-tune for Llama 2. We use title and subtitle as the doc-ID to represent a section of the document. We limit the max number of generated doc-ID as 10. And now the experimental results. This is the overall retrieval performance. We compare our model with sparse, dense, and generative retrievers. We can see from the results that our model achieves superior retrieval performance across most datasets, which shown it's effective for the unification of our model in retrieval tasks. And for the downstream performance, we consider 2 settings, including the closed book and the retrieval augmented settings. In the closed book setting, our model supports traditional language models such as T5 and BART, and even outperform the larger model Llama 2 70B across most datasets. And in the RAG setting, our model also takes lead with the Llama 2 based model demonstrating the most substantial improvements, which also demonstrates the effectiveness of our model in the downstream generative tasks. And we also conduct ablation studies. First, for retrieval tasks, when removing the doc-ID and understanding tasks, reduce the retrieval performance across all datasets for both T5 and Llama 2 based model. This demonstrates that the auxiliary task helps the model understanding the doc ID and thereby improve the retrieval performance. When changing the ranking-oriented decoding to the traditional beam decoding leads to lower R precision in most datasets, especially for Llama 2-based model, showing that the traditional beam search method will not be suitable for large decoder-only models. And for understanding the reasons why, we need to conduct more experiments in the future. And for application studies for downstream tasks, when removing the reference decoding, the noise sampling, and the continuous decoding, they all lead to a performance drop to a different extent. And we also analyzed the ranking capability of our model for retrieval tasks. And we can see from this table that our model demonstrates superior retrieval ranking performance compared to generative retriever, but sometimes slightly lower than the dense retriever, which shows that there's still room to improve the ranking capability of generative retriever. And finally, for the efficiency of our model demonstrates require lower memory footprints and require lower the query latency, for the retrieval augmented generation task. And finally, to get a conclusion, we propose a unified language model capable of utilizing the knowledge of Corpus for generative retrieval, closed book generation, and retrieval augmented generation to facilitate knowledge-intensive tasks. And we also developed two decoding strategies: the ranking-oriented doc ID list generation strategy and a reg-oriented continuous generation strategy to achieve a unified greedy decoding solution for all the tasks and to further improve the performance of our model. And finally, the unsupervised doc ID understanding tasks to deepen the model's comprehension of the meaning behind doc IDs. And finally, if you are interested in generative information retrieval, you can check out our latest survey. You can see in this figure that different from the traditional matching-based retrieval method, we explore two forms of new generation of information retrieval, including the generative document retrieval and reliable response generation. The generative document retrieval directly generates the doc ID ranking list, the new form of retrieval. And the reliable response generation is directly give the information, directly generate the information that users need. The two forms of information retrieval. And for details of taxonomy, you can see in the right figure. You can find our paper and the GitHub repo in the following link. And that's all. Thanks for listening.